high above the dark waters of the Atlantic Ocean. An Airbus A330 operated by Air France is no longer flying. 38,000 feet above the Earth, the aircraft has already entered a full aerodynamic stall. Inside the cockpit, alarms are screaming. Stall, stall. The nose of the aircraft is pointed upward, yet the airplane is falling. 10,000 feet per minute. Inside the cockpit, the pilots are fighting the controls. But the airplane refuses to recover. Outside the windows, the sky is completely black. No horizon, only distant lightning inside towering storm clouds. For the next 4 terrifying minutes, Flight 447 will fall helplessly toward the Atlantic Ocean. And the pilots will never fully understand why. This disaster would later become known in aviation history as the Titanic of the sky. Before we uncover what really happened, take a moment to subscribe. Because on this channel, we break down the most dramatic and important aviation stories ever recorded. June 1st, 2009. High above the Atlantic Ocean, the Air France Airbus A330 moves quietly through the night sky. 38,000 feet above the Earth, the aircraft cruises smoothly toward Paris. Inside the cockpit, Captain Marc Dubois has stepped away for a scheduled rest break. At the controls are the 2 co-pilots, First Officer David Robert and First Officer Pierre-Cédric Bonin. There is no flight engineer on this aircraft. Modern airliners like the Airbus A330 are designed to be operated by just 2 pilots. The aircraft is stable, the autopilot is engaged, the computers are flying the airplane. For the passengers asleep in the cabin, it is simply another overnight flight across the ocean. But ahead of them, the sky is changing. On the weather radar, towering thunderstorms appear like glowing mountains of red and yellow. The aircraft approaches a violent region of weather known to pilots as the Intertropical Convergence Zone. Lightning flashes silently inside the clouds ahead. The co-pilots begin carefully navigating between the storm cells. For several minutes, everything appears completely normal. Passengers sleep. Cabin lights glow softly in the darkness. The engines hum steadily through the night. But high inside those storm clouds, something dangerous is forming. Tiny ice crystals, invisible, harmless looking, yet capable of triggering a disaster. On the nose of the aircraft are 3 small sensors called Pitot tubes. Their job is simple: measure the speed of the aircraft through the air. But as Flight 447 crosses through the storm, ice crystals begin forming inside those tubes. Slowly, silently, the sensors begin to freeze. And when those sensors freeze, the aircraft's computers lose reliable airspeed data. But investigators would later discover something strange about this moment. Something that should have warned the pilots what was really happening. Yet in the chaos of the cockpit, no one noticed it. At 2:10 in the morning, the cockpit alarms suddenly sound. Beep. The autopilot disconnects. The aircraft is no longer flying itself. Now the pilots must take control manually, but something is wrong. The airspeed indicators begin to fluctuate. One display shows the aircraft slowing down. Another suggests it is accelerating. The information is confusing, unreliable. Inside the cockpit, the pilots must make a decision quickly. In the sudden uncertainty, First Officer Bonin pulls back on the control stick. The nose of the Airbus rises. The aircraft begins climbing sharply into thinner air. But at 38,000 feet, the margin between normal flight and aerodynamic stall is dangerously small. Within seconds, the aircraft crosses that invisible boundary. A warning echoes through the cockpit. Stall, stall. What the pilots do not realize is that the aircraft is giving them a clue that could have saved the flight. But the meaning of that warning would only become clear years later, when investigators recovered the black boxes. The wings have lost lift. Airflow over the wings has collapsed. The aircraft is no longer flying. It is falling. The correct response would have been immediate. push the nose down, regain airspeed, restore airflow over the wings. But inside the cockpit, the pilots do not yet understand what is happening. Instead of lowering the nose, they continue pulling back. The Airbus climbs slightly higher, then suddenly begins to sink. The nose remains pointed upward, yet the aircraft is descending rapidly. Stall, stall. Altitude begins dropping, 37,000 feet. 36,000, 35,000. The captain, Mark Dubois, is urgently called back to the cockpit. He rushes through the dark cabin. Passengers remain asleep, unaware of the crisis unfolding above them. When he reaches the cockpit, the situation is already critical. The aircraft is descending rapidly. The stall warning continues screaming through the flight deck. Outside, the sky is completely black, no visible horizon. Only distant flashes of lightning. The Airbus continues falling, 30,000 feet, 25,000 feet, 20,000 feet. Despite the massive descent, the nose of the aircraft remains pointed upward. An aerodynamic paradox. The wings remain stalled. The aircraft is now falling at nearly 10,000 feet per minute. Inside the cockpit, the pilots fight the controls, but the airplane refuses to recover. Then suddenly, something happens that confuses the pilots even more. The stall warning stops, not because the aircraft has recovered, but because the airspeed sensors are now giving readings so low, the computer can no longer detect the stall condition. Now the warning system has gone silent. The pilots have even less information. The aircraft continues falling. Seconds pass, altitude drops rapidly. And the most tragic part of this disaster is that the aircraft was still recoverable. High above the Atlantic Ocean, the airplane is still falling. The nose still pointed upward, the pilot still fighting for control. After nearly 4 minutes of uncontrolled descent, at 2:14 in the morning, Flight 447 reaches the ocean. Still in a full aerodynamic stall, the aircraft strikes the water at nearly 200 kilometers per hour. The impact destroys the aircraft instantly. All 228 people on board are lost. The wreckage disappears beneath the dark waters of the Atlantic Ocean. In less than 4 minutes, a modern airliner had disappeared into the Atlantic Ocean, leaving behind one of the greatest mysteries in modern aviation. For days, search crews scan the ocean's surface. Small pieces of wreckage begin to appear. But the main aircraft remains hidden, nearly 4,000 meters below the surface. It will take almost 2 years before investigators finally locate the wreckage on the ocean floor. When the flight recorders are recovered, experts from the Bureau of Inquiry and Analysis for Civil Aviation Safety reconstruct the final minutes of the flight. And when they listen to the cockpit recordings, they discover something heartbreaking. Even in the final seconds of the flight, the pilots still did not realize the aircraft had stalled. The frozen Pitot tubes triggered the chain of events. But the investigation reveals a deeper problem: confusing flight data, unexpected aircraft behavior, and pilots who never fully understood what their aircraft was doing. The tragedy of the Air France Flight 447 crash would lead to major changes in pilot training around the world. Because sometimes, the greatest danger in aviation is not mechanical failure, not violent weather, but the moment when pilots lose understanding of what their aircraft is truly doing. 4 minutes high above the Atlantic Ocean. 4 minutes that turned a routine flight into what many would later call the Titanic of the sky. 4 minutes that changed aviation forever.